with you. And I say good morning to everybody. And today we are going to talk about battery energy storage and renewable energy conversion system. I hope that everybody can see my screen.
Yes, we can see the screen very well.
Okay, very good. Okay, first of all, I'm Robenson, and my background is mainly on electromechanical engineering and energy engineering. Then I've been working in the energy sector in projects such as rural electrification, grid feasibility, electrical design, PV design, and energy storage solutions, and among others. But in today's class, we are going to focus on energy storage. That is a very useful and promising area of research and technologies that is very mature at this time. But what happened is in electrical grid, we are often dealing with some problem, with some issues. And to mitigate those issues, one of the promising way to do this it is the use of battery energy storage system. But first of all, to understand all of that, we have to talk a little bit about electrical grid. What is an electrical grid? An electrical grid has globally this structure. So the structure is this. We have the generation at one hand, and at the other hand, we have the consumption. And between, we have the transmission, we have the distribution. Sometimes the transmission is over long distance. Why? It is because the place where we can generate is not usually the place where people live. Okay, or where people live, maybe is not the place where there's the energy potential. Therefore, we need to build all of those infrastructure. So we will have the generation where we produce the energy, the transmission line, and the distribution line, and at the end, the consumption. But we always have to deal with a fact. The fact is the offer and the demand, the generation and the consumption. At any moment, at any time, the generation should be equal to the consumption. But sometimes it is not what happened. For instance, in this case, we can observe that the red line is the generation curve and the blue line is the load curve. For instance, in the morning, we can see that the load curve is above the generation curve. So this means that there is a lack of production. But in this interval, we can see that the generation curve is over the load curve. So this means that we have an excess of energy production. Then at the end, we can see it is the opposite. And the only period where the energy consumption is equal to the energy production is in those 2 points. This point and at this point. Let me use the last pointer. This point and this point. So to mitigate this problem of sometimes we have a lack of production, or sometimes we have an excess of production, we have to think about energy alternative in order to deal with the excess of energy or to fulfill the lack of energy. Then as an energy alternative, we can think about the renewable energy sources. For instance, we can mention wind energy, solar power plant, and some renewable energy sources like biomass, like hydroelectric, and biofuel cell, etc. But to integrate these renewable energy sources, we have to design energy conversion system, because without energy conversion system, it is impossible to take advantage of the renewable energy sources. So it is an important part of the renewable energy integration. Now let's see what is the main part of an energy conversion system. And after the generation, like the power plant, we have the machine side converter. The machine side converter helps us to convert the energy that that come from the generation, and we will put it in a way and in such way that we can make the compensation. The compensation is like when we are going to put filter, or when we are going to adjust the voltage. So we can put it in the convenient way so it can match to the input of the grid side converter. The grid side converter is like an inverter that will convert from DC to AC in order to inject to the grid. But before the injection to the point of common coupling, what we'll do, we'll measure, and the measurement is in order to take feedback. So those feedback will help us to design convenient controller, and the controller is in order to set the correct modulation index to the inverter, so it can perform correctly, so it can provide the right voltage, the watt power, so we can respect the grid standard or the grid requirement. Then we have to design the protection for the energy conversion system. When I'm talking about protection, I'm talking about a system that will help us to deal with things like voltage sag, voltage swell, and harmonics. Therefore, that's our important part of an energy storage system. Then we have the injection. The injection is where we are delivering the power at the point of common coupling, or when we are delivering the power to the grid. Now let us talk about renewable energy sources. As renewable energy sources, we all know that it is about solar, wind, hydroelectric, biomass, geothermal energy, tidal energy. All of those are renewable energy sources. But to be able to take advantage of those renewable energy sources, we have to design energy conversion system, and also we have to take into account the issues and challenges that are related to these renewable energy sources. For instance, we know that there is a fact of variability or intermittency that is linked to the renewable energy sources. Therefore, when you're talking about renewable energy sources, we have to deal with uncertainty, fluctuation, because due to climatological fact, we cannot be sure at every moment that the sun will blow all day long, or we cannot know if today we will have rain or not. So this is a testimony of the uncertainty of the renewable energy sources. Then we have the power density and the power quality, because due to the fluctuation, we cannot have a given value or a fixed value for the output power of a given renewable energy sources. For instance, if the nominal power of my solar power plant is 15 kilowatt, So if my irradiation fall from 100 watt per square meter to 500 watt per square meter, so I will not have 15 kilowatt. I will have half the nominal power. Therefore, I have to deal with the power quality. Also, there are power losses. The power converter and the power converter are based on on switching system. So due to the switching system, we are having loss. And also, in the power converter, we are using some passive component like a resistor, transistor, and inductance. So we have losses in those components. So due to these losses, we have to bring some mitigation. Also, there is the fact of maturity in order to energy alternative. Therefore, we have to bring something else that is going to represent a complement to the renewable energy sources. And this is part of the mitigation and compensation. And as mitigation, what we can do, we can set some control strategies. The control strategies are some disposition that we can take in order to overwhelm these issues. Also, we can use the historicity. For instance, we can use the data of for the past 10 years or for the past 20 years in order to see, for instance, in the month of September, how was the wind speed profile, or how was the irradiance profile for the sun. Therefore, we can have an idea, and with this, we can make a predictive analysis. But this is at the side of the generation. But also, we are dealing with load uncertainty. So due to this, we can use the data of the previous load for the past 5 years, past 10 years, in order to design a load forecasting. So load forecasting helps us to have a predictive load profile that is so close to the real load profile. And this will help us to design control strategies in order to well design our power system so we can match the situation where production is equal to consumption, because this is always what we are looking for, and an equilibrium between generation and consumption. Also, one thing that is very useful, it is energy storage system, because with energy storage system, we can realize all those things. So let's see an energy conversion system and the reality. And the reality, for instance, if I have a wind farm where this is the wind turbine and this is the generator that is linked to the wind turbine. So if someone here doesn't understand how it works, I can explain it rapidly. The wind turbine produces mechanical power. So the mechanical power is sent to a generator, and this generator, for instance, here we are dealing with a permanent magnet synchronous generator, and this generator transforms the mechanical power into electricity, three-phase alternating electricity. So this AC electricity is transformed into DC energy through a rectifier. So this rectifier is a converter, as you can see. So it helps us to pass from AC to DC. And here we have the DC link. Why do we have this capacitor? This capacitor is like an element of storage that helps us to make a kind of regulation in the power or in the voltage. And also it helps us to deal with the ripple, because after the rectification, we will not have a constant value for the voltage, even though it will be a direct current, but we will still have some ripple. So in order to deal with the ripple, we use this DC link that is like a buffer. So this buffer will help also to reduce those kind of problems, because if we do not bring a solution to this problem, after this side, we will have a lot of rate of harmonic, and this is not permitted to send to the grid. So after this DC side, we will use an inverter. The inverter is the grid side converter that will convert from DC to AC. And then here we have an AC voltage, and this AC voltage and the AC current also is filtered by these low pass filter and RL filter that help also to reduce the THD, so we can respect the requirement or the grid standard. Then you can see that we have the power part, and also we have the control part. Why do we have this control part? Because if we inject directly, if there is a problem, like if the frequency of my system is not equal to the frequency of the system, I will not be able to manage this problem. Or if the voltage is not the same, I will not be able to manage this problem. Therefore, it is necessary to have the system to take a feedback and then send it to a controller, and then the controller make a comparison with some reference value, for instance, reference voltage, reference current, and then the error is sent to a PI controller, and the PI controller helps us to make a regulation, and then we send a modulation index in order to control the inverter, so the output of the inverter can be equal to the grid standard or the grid requirements. Therefore, it is a normal energy conversion system, or better, a real energy conversion system. But you can notice that this real energy conversion system is only based with this controller in order to bring power quality. But sometimes there are other type of problems that the controller cannot deal with. That is why we will need the battery energy storage system. Later, we will see how to integrate the battery energy storage system. Now, let's talk about energy storage system globally. Globally, what is an energy storage system? The energy storage system is like a set of equipment that we use in order to store energy, and the energy can be stored in a different way. That's why we can classify the energy storage system into, there's 5 main categories. There are mechanical energy storage system, electrical, electrochemical, chemical, and thermal energy storage system. And in today's class, we are going to focus on the electrochemical energy storage system where we find the batteries, the flow batteries, and the electrochemical capacitors. So let's see some applications of the batteries. With the batteries, we can achieve energy arbitrage, peak shaving, load following, voltage support. For instance, now I'm working on this part. I'm working on a voltage support using battery storage system. It is like, for instance, as I show you in the energy conversion system, when we arrive at the DC side, sometimes you cannot directly achieve with the reference value for the voltage. For instance, if my reference value is 120 volt, sometimes I will have 100 volt, or I will have 110 volt, or 130 volt. So in order to adjust the voltage so it can be equal to the reference value, I can use this type of application that I can do with the batteries for voltage support. So with the batteries, we can achieve this goal. We can have the reference value for the voltage. And also we can achieve frequency regulation, power quality, power reliability, and renewable energy time shift. And this is an important part because what happens, it is sometimes when the energy is available, it is not the time when we are at home or when we need the energy. And at the opposite, when we really need the energy, sometimes the energy is not available. For instance, if we need energy at night, but if we are dealing with a solar power plant at night, there is no sun. So what we will do? So this is how we can achieve renewable energy time shift. What we will do is use battery energy storage system in order to store solar energy when solar energy is available. And then when we will need to use this energy, so even though solar energy is not available at this time, so if we are at night, so what we'll do, we will use the energy from the batteries. And other reason that we can use in order to make renewable energy time shift is sometimes when we are at the peak hour, the cost of the kilowatt, it is more expensive. So what we can do, we can store energy in off-peak time. And at the peak time, we will use the energy stored in the batteries instead of using the energy that is coming directly from the utility grid. So this is a kind of a way that we can use in order to reduce the load profile or reduce the gap between the peak load and the base load. And also it is a way to pay less for the for the energy services. So now we can see that there is a lot of things that we can do with the batteries. And there is something that we have to understand. There is a different type of batteries. We have primary batteries. The primary batteries are those that we cannot recharge. But the secondary batteries are rechargeable batteries. And among the rechargeable batteries, we can distinguish the lead-acid batteries, nickel-based batteries, sodium-sulfur batteries, lithium-ion batteries, and flow batteries. But The more common use of batteries nowadays is lithium batteries due to their advantages like high energy density, high power density, and low self discharge. Therefore, they are very useful, and they are very promising technology nowadays. And to talk about batteries, also there are some important concepts that we should know. For instance, we can talk about the state of charge. The state of charge, it is the amount of energy that is available on the battery. For instance, is if my battery is fully charged, so my state of charge is at 100%. But if my battery is completely discharged, my state of charge is 0%. And at the opposite, the depth of charge, it is how deep we discharge our battery. For instance, if my battery has a state of charge, so this means that the depth of charge of my battery at this time, it is 40%. Also, we have some terms like energy density, power density, that are the rate of energy available per volume, or the rate of power available per volume. Also, we have the power rating. The power rating is like the nominal power of the battery. And the lifetime, it is the number of years that the battery can last if we are using it in the right way. Like if we are not discharging the battery completely. So this is an idea of the lifetime. Of the lifetime. And the cycle time is the number of process from discharging completely from fully charged to completely discharged. So this is a cycle. And we have to know that when we are dealing with a lithium battery, we have to reduce the number of cycles, because it is the number of cycles that determines the lifetime. Therefore, we have to reduce the number of cycles, and also it is not good to fully charge your lithium battery, and also it is not good to fully or to completely discharge your battery. Therefore, it is important to define a strategy for the operation of the batteries. Also, we have the self-discharge. This means that even when my battery is not connected, it can be discharged. And it is one of the advantages of the lithium batteries, because their self-discharge is very low, very, very low. Therefore, it is a very nice technology if someone is using a battery storage system for renewable energy. So lithium battery is a good option. Also, we have the response time and the maturity. And the term maturity in this area mean that if a technology is quite good, so non-professional people can use it without too much care. So this means that it is a mature technology. Now let's talk about the case of the lithium batteries that are promising battery. So the principle is quite easy to understand. It is a reaction that is realizing inside the battery, and this reaction will release some electrons, and the flow of electrons outside the battery will give us the current. It is as simple as you can see. And the real reaction that really happened inside is this. So we can see that what happened at the positive electrode is we have this element, there's a lithium cobalt oxide, and after the reaction, what we will have this part and this ion, lithium, and also we have the release of electron. And it is this electron, this flow of electron that will create the current flow. And also, this is for discharge, and when the battery is charging, so the flow of electrons go inside the batteries, and then we will have the inverse of the process. Electrically, this is how it looks like. So this is the Thevenin equivalent model of a battery. Therefore, we can see this is the expression of the current of a battery, and this current, we can use it in order to determine the state of charge of the battery, knowing the state of charge of the battery at an initial time, T0, and the efficiency of the battery and the overall capacity of the battery. So why it is important to know the state of charge of the battery? It is important because it is with this state of charge that we can design a control strategy or design a battery management system, because it is important to have a battery management system so the battery energy storage system can operate in a convenient way. Now, let's see how to integrate the battery energy storage system. I hope that you remember the energy conversion system that we saw earlier. So it is the same thing, but at the DC side, what we will incorporate, it is the energy storage system. And you can see, in order to incorporate the energy storage system, what we do, we introduce a converter, another converter. Why do we introduce this converter? For instance, is at this boost, we have a voltage of 300 volts, and I have to integrate my battery. Without this, my battery storage system should be at the same level, like 300 volts. But what if it is not easy for me to implement a battery energy storage system at this voltage level? So it is possible to implement it at a lower level or at a higher level of voltage. So in this case, we implement the battery energy storage system at a lower level of voltage. For instance, if you have 150 volt or 100 volt, therefore we will use a buck. This is a bidirectional converter. There is a buck side and a boost side. The buck side, it is to step down, and the boost side, it is to step up. So when there is a excess of energy here, so the command of the battery management system will be to store energy. And when we will store energy, we will active the buck side. So we will step down the voltage, and the flow of energy will be from the boost of the DC link to the batteries. But what if we have a lack of production? So when we have lack of production, what we'll do in order to respect the requirement of the grid, for instance, if at any moment I have to inject 10 kilowatts, and if I have a lack of production, so lack of wind, so my wind turbine can only produce 5 kilowatt, and I have to inject 10 kilowatt. So what I will do, I will use the energy stored in the battery energy storage system in order to support the renewable energy sources. So the other 5 kilowatt, I will take it from my battery energy storage system. And then in order to do this, through my battery management system, I will activate the boost side. Therefore, if the output voltage of my battery storage system is 100 volt, so I will step up the voltage so I can synchronize at this boost that is at the level of 300 volt. Therefore, the ratio of conversion of my boost converter should be 3 times. So this is how I can implement a battery energy storage system globally. Therefore, we can deal with these common issues in electrical grid, like power outage, power fluctuation, as we have just seen, load unpredictability, because sometimes when the production is not varying, it is the load that is varying. So we have to deal with generation uncertainty and load unpredictability. Also, we have a voltage sag and swell, and also we have the cost that we can deal with. And the cost, we have just seen that we can store energy when we are in an off-peak period, and we know that in off-peak period, the energy cost is lower. So we can use the stored energy in a peak period. Because in a peak period, the cost of the kilowatt hour is higher. So in order to deal with these issues, we can make the compensation with the battery energy storage system, like power smoothing, like if the power curve is varying, like if there is a lot of ripple, we can smooth the output power so we will not harm the sensitive equipment. Also, we can make the energy management. The energy management is like to store when we have excess of energy, and release when we have a lack of energy. Also, we have the load leveling, like when we are trying to reduce the gap between the load peak and the base load. Also, we have the black start. For instance, if we had a power outage, sometimes in order to start again with the conventional power plant, like a power plant that is functioning with, that is operating with fossil fuel, what we can do, we are requiring power from the grid, from the global grid, in order to start with a little power plant. But if we had a energy storage system integrated in this power plant, so we will not need to require power from the grid. We will only need to activate the battery energy storage system in order to start the power plant. Like for instance, sometimes we are dealing with generators that have that need excitation current in order to start. So this excitation current, we can provide it with the battery energy storage system. So at this point, we will not need the grid support. Also, we have voltage regulation and control. That's what I was explaining when we use the feedback in order to make the control. And then from the control, we send the correct modulation index in order to control the inverter. So the output of the inverter will synchronize directly with the grid voltage and the grid frequency at the point of common. As we were talking about battery energy storage system, how to design a battery energy storage system. So we have to take into account, first of all, the amount of power that we will deal with. For instance, if we will deal with 10 kilowatt for the battery energy storage system, this is the first information that we have to take into account. Later, there is the autonomy. For how long I will have to provide the 10 kilowatt, or for how long I will have to store the 10 kilowatt. For instance, I can imagine that I will have to do it for 2 hours. So when I multiply the power by the autonomy, I will have 10 kilowatt times 2 hours. So I know that the energy that I will have to store will be 20 kilowatt hour. But this is the energy that I will have to store, but not the capacity of my battery energy storage system. Because in order to design the system in terms of capacity, we have to take into account the converters, the efficiency of the system. So also we have to take into account the coupling voltage. So we will know the type of the battery that we will use. For instance, if it is a string of battery of 2 volts, or if it is 12 volts, if it is 45, if it is 24 volts. So this, the coupling voltage will battery. Then we have the converters. The converters are not ideal converters. Therefore, they are switching loss. And due to the switching loss, we have an efficiency that is below 100%. For instance, it can be around 95%. So this will affect the capacity. Also, there is the level of use. When I'm talking about the level of use, it is because we cannot completely charge the battery, neither we cannot completely decharge the battery. Therefore, it is important to design a battery management system. And also, we have to take into account the efficiency and the level of use. If we will use the battery at 80%, and we will use, and the efficiency of the converter is 95%, therefore, we know that the capacity of the battery will be the energy that we should store or provide, that we will divide it by the efficiency and by the level of use. Then we will find the capacity of the battery energy storage system. Now, let's see how to implement the battery management system, the BMS. So it is important to define a minimum and a maximum for the state of charge. For instance, I can define for my battery management system 10% as the minimum and 90% as the maximum. Therefore, I will use 80% of the capacity of my battery energy storage system. Also, I have to define when I will have to charge my battery and when I will have to release energy from the battery. So the algorithm is like that. For if the power of the source, like the generation power, is higher than the reference power, so the flow of power that goes between the DC boost and the battery, this flow will be positive. So this means the power will come to the battery. So the battery will be charging. But if there is a lack of energy, which means the generation power is less than the reference power, therefore, the flow of power will be from the battery to the DC boost, and then my battery will be discharging. But if there is an equality, so here I should put the equality sign. Sorry. If the power, if the generated power is equal to the reference power, therefore the flow of power from the battery to the DC side will be 0. So this means my battery will be in standby mode, because I am in a perfect situation where the generation is equal to the consumption. So I don't have to use the battery energy storage system. So we have just seen how to use battery energy storage system in such a way we can support the renewable energy integration into the grid, as it is a promising part nowadays, because in order to reduce the CO2 emissions and to reduce the use of fossil fuel, it is very important to think about energy alternative. And one of those alternatives is renewable energy sources like solar, like wind, like biomass, like tidal power. But we know that those kind of renewable energy are variable renewable energy. Therefore, we have to deal with intermittency, we have to deal with unpredictability, we have to deal with power quality issue, we have to deal with other kind of issues like voltage saga, voltage swell, harmonic component. Therefore, one of the way we can mitigate this kind of problem, or to compensate this kind of problem, it is the use of battery energy storage system. But how is it nowadays? Nowadays, the leading technology in battery energy storage system is a lithium battery. And in terms of the material used, like for the electrode, the leading technology is the lead of lithium, nickel, manganese, cobalt oxide that is available at 60% on the market nowadays, and the electrode with lithium iron phosphate that was leading the last decade, but now it is behind the lithium, nickel, manganese, cobalt. So the lithium iron phosphate is nowadays available at 30%. And the challenge is to bring more maturity in this technology, also to reach higher density in terms of power density, in terms of energy density, also to reduce the cost. That is why some of these technologies are still under investigation in order to find new materials that will help us to bring more stability, more efficiency, more density, and at lower costs. And we can see that the trends nowadays is, for instance, the annual added battery energy storage system for the year of 2023 is between 100 to 140 gigawatt hour. And we can see that the goal for 2030 will be between 500 and 700 gigawatt hour for capacity added for battery energy storage system. So we can see through this graph that it is something that is well understood that this technology is really needed. It is needed for renewable energy integration purpose, for utility grid purpose, also for electrical vehicle purpose, because on this side also they are using a lot of technology of lithium, and it is a very promising way. It is a very promising technology nowadays. So thank you, everybody. And if you have any question, it is time for question. Thank you for assisting.
Thank you very, very much, Robenson Jean. Your presentation was really awesome, great from all vantage points. We're talking about a field that is very highly in demand all over the world. And very unfortunately, like you explained, the alternatives very often are not really an excellent remedy, which is the reason why a good focus of your presentation was on battery energy storage system. We've had a lot of questions on the chat line.
Question, let me see.
I am hoping that we're gonna be able to dedicate enough time to those questions. Before I see any hand up, let me go back to one of the issues that I saw on the chat line. As I said again, there have been many. In renewable energy, I'm so sorry. You may remove your slide, your PowerPoint at this time, so that we can see all the faces in a mosaic format. Jean, just in case a hand is up and we do not spot that hand on time, you can just close your presentation.
Okay.
From your
I can try to answer some question that I see in the chat. For instance,
okay, go ahead.
There is Sani Mohamed Sambo. The question is, when can we change a battery, and when can we resuscitate it? Okay. When can we change a battery? As telling it, we can see that there is some important concept that we have to understand when we are talking about battery energy storage system. For instance, here we can see that there are two important terms. That is the lifetime and the cycle time of the battery. So this will depend on the lifetime of the given technology that we are using, the type of battery that we are using. For instance, if it will be different if we are using lithium batteries, and also it will depend on the use of the battery. This is why it is important to understand those concepts in order to well use the battery. For instance, my lithium battery can last for 5 years till 7 years, for instance. But this will depend on the user. For instance, if you're using, anytime you're using your battery, the depth of charge is at 0% or near 0%, in my battery, when I'm using it, I'm only use 50% of my battery. So my battery will last longer than your battery because you use it completely. Okay? So it is important to know that for lithium battery, you can reach till 80%. But for lead acid battery, you can use like around half the capacity of the battery, like the half of the depth of charge. Therefore, depending on the user of the battery, it can be 5 years and it can be less, it can be a little bit more, depending how good you use the battery. Perhaps if you're designing a global system for a solar power plant, there are some software that you can use, and the software will tell you, depending of the applications or depending of the size of the system, or depending on the rate of charge and discharge of the battery, the app or the software will tell you how long you can use the battery. For instance, there is a software, the name is Homer Pro. I can write down the name and the chat for you. With Homer Pro, you can design your system like give the load profile, predict the generation, and then design the battery energy storage system. And after the render will tell you if you can use it up to 5 years or up to 10 years, for instance. But most of the times, it is better to use the battery for 5 years. I see that Antwi Daniel raised hand. Go ahead. Antwi Daniel. Maybe Daniel is not here. Another question?
Let me interrupt real quick, Robenson, to read a question that I saw long ago on the chat line by Dr. Jean. Actually, she has more than one question, but we're gonna to allow participation of other people presently in attendance. Let me read just a portion of the questions from Dr. Jane. She's asking, in renewable energy conversion system at controller level, what normally happens when the meter reading is flashing? Does that mean that the central meter database is faulty, or is it operational mischief? I don't know if you can address that for Dr. Jane Robenson.
Yes. In order to answer correctly, let me show something to the person.
Reminding you, ladies and gentlemen, you are with Atlantic International University with that presentation by Robenson Jean on renewable system, and particularly storage of battery energy. Go ahead there, Robenson.
Yes. What happened inside? So in the presentation, I didn't show what happened inside the controller in order to avoid buttering, because it is a kind of it is a lot of stuff inside. But I don't know if you can see my screen here. You can see what happened inside. Inside the controller, there are two levels. the first level, it is the voltage controller, and the second level is the current controller. What happened? Here at the DC side, before or at the end of the inverter, we have a reference voltage. Why do we have a reference voltage? It is because we need at the output to have a voltage that can match or that can synchronize to the grid voltage in order to respect the requirement of the grid operator. So if we do not have the required voltage at the input, so at the output, we will not have the desired output voltage. Therefore, we have to track the reference voltage at the input. So in order to do this, one way we can achieve this control, it is to make a measurement with this meter, where we will read the wheel voltage. And then here inside the DC voltage controller, we will compare the read voltage to the reference voltage. And we'll have an error. The error will be set to a PI controller, and the PI controller has a calculated gain, and this gain will help the PI controller to send an output, and the output will be a reference power. The reference power will be set inside a current controller. So inside the current controller, what will be done? We will divide the power by the voltage of the grid. Once we divide it by the voltage of the grid, we will have the reference current, because you know that power is equal to voltage times current. So we'll have a reference current. So this reference current will be compared to the read current, because here you can see that we have read the current. So we compare to the current, and also the error is set to a PI controller. And then after the PI controller, we will send a modulation index, and this modulation index will be set to the inverter. So the inverter can operate as expected. And then if here at this point, the voltage was not exactly equal to the voltage of the grid, so in the next iteration, the voltage will be closer to the voltage of the grid. And this iteration will repeat until the output voltage of the inverter will be equal to the voltage of the grid. So globally, this is what happened. But if I will have to explain all the mathematical stuff that we have inside, it will be so long. But globally, this is what happened. Go ahead, Caleb Magutu.